Hi, you right? Welcome to your lesson on pressure in solids. So starter for today, 3 questions there. What is the calculation of the force of weight? What is the unit for weight? And what is the unit for mass? Pause the video and answer those questions, please. The purple pen, weight equals gravity times mass. It's measured in newtons. Remember, weight is a force and mass is measured in kilograms. So pressure in solids is what we're looking at today. How many ways can you break a window? Not that you should break a window. Spend 5 minutes writing down all the ways that you could break a window. Pause the video to do this. Okay, now whatever ways you've listed, the key thing is there must always be pressure associated. Pressure is always required to deform. Remember, thinking back to previous lessons on squashing and stretching, deform means to change the shape of a solid. So in this case, you'd be changing the shape of a window, so it's no longer one piece, but lots of different pieces. Okay, so high pressure and low pressure, this is something that we probably already know without really thinking about why. So a force spread over a large area produces a lower pressure. We've got 2 pictures there. We've got the gentleman's shoes and the lady's shoes on the right. So which type of footwear would be better for standing on a muddy field? The flat-soled shoes on the left or high-heeled boots on the right? Have a think and think about why as well, please. So the shoes that have flat soles, so they spread the person's weight over a large surface area. These shoes, exert a low pressure on the ground. In contrast, the soles of the high-heeled boots have a smaller surface area because of that thin heel at the back, and so exert a higher pressure. These shoes are likely to sink into soft ground. So what factors affect pressure? What do these images show you about how pressure can be affected? Have a think, and then we'll move on to our next slide. Okay, now we've got various more pictures here, and these objects rely on either low pressure or high pressure. How do they achieve this? Okay, so think now, pause the video and make a list of which ones involve using low pressure, which ones involve high pressure. Think about how. Pause the video to do this. Okay, so if we go through them, top left, snowshoes, they rely on low pressure because they require you to spread your weight so that you're able to walk on top of snow. That's the function of a snowshoe. Coming across, hypodermic syringe in the middle, the type that we have any injection with. This relies on high pressure by having a very, very thin needle, so it's able to easily pierce the skin without doing any major damage to the skin. Bed of nails on the top right relies on low pressure. We know that a nail individually on its own has a very high pressure because it's got a very small point, but the bed of nails relies on many, many nails all together in order to spread that pressure out between lots of different nails, so increases the surface area. The camel's foot, you see there the picture, very, very large, very, very wide. Again, that is low pressure, a bit like the snowshoe for walking on top of the sand, so don't sink. Sharp knife, high pressure. We need a thin, sharp blade in order to cut the tomato. And the comfortable chair is low pressure because you don't want to put lots of pressure on your body. It doesn't make it as comfortable sitting down. So the experiment that we would normally do as part of this lesson is investigating the depth of sand displacement from different types of block. So we look at different shapes of block and drop them, see how deep they go into the sand and how wide. Now, if we think back to the pictures of the shoes, if we've got something that's very pointed, we would likely expect it to go deeper into the sand and have a smaller width. If we've got something like the flat-soled shoes, they wouldn't necessarily go that deep, but would be much wider. So this is our practical method. Drop each type of block into the sand from the same height. Use a ruler to measure the depth and width of sand displacement and fill in your table. So on here, what I'd like you to do, please, is in your books, make a list, please, of the different variables. So remember, independent variable is the variable thing that we change about the experiment. Dependent variable is the thing that we measure in the experiment, and control variable is what stays the same. Pause the video and note those down in your book. Okay, so the independent variable, the thing that we are changing, is the type of block, the shape of the block. The dependent variable, what we're measuring, is the depth and width of the sand displacement. And the control variable here, we've got it's the same height. You also need to make sure it's the same sand, and the sand is level before each experiment. Right, can you copy and complete this in your books or on your paper? Keywords are down at the bottom, so copy this and add the keywords. Pause the video to do this. So purple pen, solids with a large surface area require more force to be used to break other solids. This is because the pressure of the force is spread over the large area. A much smaller amount of pressure can be applied to an object with a small surface area to cause the same damage. So this is things like if you're trying to put a nail into a wall, a nail would have a very thin point, so it's easy to hit in, whereas if you use something that is much wider, you would require a lot more force to get it into the wall. So just a quick reminder, how do you work out the force of weight? Force of weight is an object's mass times gravity. So on Earth, gravity is 9.8, or we usually just round up to 10. So mass times 10 would give the force of weight. Mass, remember, needs to be in kilograms. This is an important formula triangle, so note this down, please. So pressure, PA stands for pascals, is equal to the force normal to a surface in newtons divided by area of that surface. So force is equal to pressure times area. So for the example question, a cube box has a mass of 10 kilos. It has a surface area of 0.04 meters squared. What's the force of pressure on the box at the table? Gravity is 9.8. We would round it to 10. So here we've got 10 times 9.8 is 98. The force is newtons. Area is 0.04. So pressure equals force divided by area. 98 divided by 0.04 is 2,450 pascals. Okay. So important to note as well, we can write pressure in either newtons per meter squared or newtons per centimeter squared, depending on what the measurement has been done in. Right. 3 sets of questions here. You don't need to answer all 3 of them. You need to choose one set. So there are 4 questions and they're all 1, 4 in the most, 4 in the sum. 3 in the sum. So choose which set you want to do. All is the easiest set of questions, sum is the hardest set of questions. Choose those, pause the video, answer the questions, and then we'll look at the answers. Okay, here are your answers to purple pen. So go through, mark your answers, change what needs to be changed. So these are all examples of where pressure is reduced by increasing the surface area. So we've got foundations for buildings, snowshoes, elephant on 4 feet, drawing pin. The top of the drawing pin is designed to reduce pressure. So big area means small pressure. These are examples where we increase pressure, so stiletto heels, ouch, sharp knives, drawing pins the other way up, and an elephant in high heels would definitely be very high pressure. Okay, so the egg will crack if it experiences total pressure above 250 pascals. Will the egg crack? The cat weighs 2.2 kilos and each pore is 4 centimeters squared. Pause the video and have a go answering this. Okay, so force of the cat, 2.2 times 10, 22 newtons. Area in meters squared is 0.04 times 4 equals 0.16 meters squared. Therefore, pressure is force divided by area. 22 divided by 0.16 gives us 137.5 pascals, and therefore the egg will not crack. Okay, that's the end of your lesson on pressure in solids. There are more questions for you to answer on the Google Forms if you're doing it on there, and I will speak to you in the next lesson.